All right, looks like it's 6 o'clock now. We're gonna get started now. So welcome everyone to our session 7. We're almost at the end of all our sessions. Before, so what we're gonna be going over today, we've got industry spotlight again, and then the two things that we're gonna be going over in today's session, we're gonna be learning about collisions and about using images. Before we get started though, we're going to have another poll question just to start things off. All right, so we've closed the polling for that. All right, let's get started with today's session now. So how good is a computer's nose? So there are studies that are showing that dogs can detect diseases by smell, sometimes being up to 99% accurate. I've heard some stories actually that there was some dogs that were trained to sniff out COVID. It was in Britain. It's pretty amazing. And now there's a team of researchers at MIT, and they're working on a way to automate the smelling capabilities using a machine learning process. So they have a system that can detect the chemical and microbial contents of air samples, and they've got a greater sensitivity than even a dog's nose. That is really pretty amazing. So a lot of potential to detect diseases. Like if people are sick with COVID, then there might be something in the air. Might be able to find that just by collecting air samples. It's amazing. All right, so we're going to do a little review of what we learned last session. So last time we were learning about functions. So the functions, they're the blocks of code that we can group together for easy reuse. So there's the syntax for defining those functions. So we use def, give the function a name. We have parameters which are optionally, we would list them out. And then we have the function body where we put in all our code. And then optionally, we can return a value from it as well. So then after defining the function, you can use it. You refer to it using the name. So you have myfunc, and then if there's parameters, you put in the parameters. And then if it has a return value, you could store that in a variable as well. So some functions, they can take in the parameters. So if it takes some parameters, you would list them out when you're calling them. And you can also store those results in the variables, as you can see in there. So here we have x equals 2 plus 2. So when we call 2 plus 2, it returns a value. That value gets stored in the variable x. All right, so the first topic we're going over today is going to be take up most of the content we're going to be learning is going to be focused on the collisions. So what are collisions? So collision, it's just when a object is making contact with another object. So on the right, we can see that we've got a moving red square, and it collides with the sides, bounces off the. It can collide also with this other blue rectangle. You can see it's bouncing off of those. So you might have had some practice with having things bounce off of the sides of the screen, but we're going to be going a little bit more of how can we make things collide with any object that we want. So how do we make the collisions work? So to be detecting these collisions, we're going to start by going through what we're calling bounding boxes. So the bounding box is going to be representing the edge of this shape. So it's going to be a rectangular shape. And so here we have, on the left, we have our rectangle image. And then we are going to have a bounding box, which is just representing the edges of that shape. So when when the bounding boxes of two shapes are overlapping, that's when we are having a collision. So in the first case here, we got two rectangles, And we can see that the bounding boxes, they're not at all overlapping, they're completely separate. So we don't have any collision. But when those bounding boxes do overlap, so we can see that in this section here, those two bounding boxes are overlapping with each other. So for defining our bounding box, it's going to be a rectangle. It's going to have a rectangle shape. So we need to have the top left-hand corner. So we have the XY position of the top left hand. So in this case, we have the X is 0, the Y is 10. And then we need a width and a height, and that's going to define that rectangle shape. So to create these bounding boxes, we have a new function. So the function is called bounding_box. It has the same parameters as the rect function. So it has the, as I said, it has X position, Y position, width and height. And that's going to define a rectangle shape, but it's going to be a bounding box. So after calling this function, the bounding box, it's going to give us a return value, and we're going to want to store that in a variable. And that variable is going to it's going to contain the position dimension of that bounding box. So it's keeping track of the bounding box that we want. So here we can see there's the code for that. So creating that bounds, we have bounding box, X position, Y position, W and H being width and height. So you're going to see that this bounding box is going to be overlapping with this rectangle. So you would want to match these up so that our bounding box is overlapping with whatever image, whatever thing that we want to be testing the collision with. So once we have that bounding box, we can check if the two of them are colliding using a new function that we've got that's called collided. So you call collided, you pass in the first bounds and the second bounds, and it will return whether there is a collision or not. So we create the two bounding boxes using the bounding box function, and we pass both of those as parameters to the function collided. So the return value will be true if they are colliding, false if they're not colliding. So in this case here, if our bounding boxes, if there's no overlap with them, they're not colliding. So when we call this function collided bounds1, bounds2, that's going to be false. But as soon as the two shapes are overlapping, then the collided will be returning true. So in this case, we have an overlap between the two bounding boxes. So that means that they are colliding. And so our function collided bounds1, bounds2, that's going to return true. All right, so we got our first quick question. Which of the following statements are true for the collision shown in the picture? All right, so it looks like we had most people, almost everyone answering that collided bounds1, bounds2 will be true. So that is the right answer. So remember that bounds1, bounds2, that those ones are our bounding boxes. So those ones they're not going to be true or false. Those are just referring to our bounding boxes. It's the function that we have to call collided, and that's how we get the return value of true or false. So it looks like almost everyone got that correct. All right, so for using the collided, we create our two bounding boxes. So we'll store those into variables. And then we'll want to use an if statement. So the if statement is going to let us run some code whenever they are colliding. So we'll put inside our if statement whatever logic that we want to happen when that collision does happen. So for example, if we want to change direction of something, if you want to remove an object, have something stop moving, etc., all those possibilities there. And then if things are not colliding, you can have an else if they're not colliding, but mostly you'll just use most of the logic will just be inside the if when they are collided. All right, so here's our first example. So we're going to code this up. So we can see in the example here, we've got a red block and a blue block. They move towards each other, and then when they collide, they bounce off each other. All right, so I'll start with let's putting in our setup function. Make the size 500. Let's do our draw function. And inside the draw function, we're going to want to draw our background. So let's do the purple background. And let's start with just drawing the two rectangles. So we'll start with the red one. So to make it red, we'll use fill style, make it red. And then we'll draw the rectangle with the rect function. And let's start with a XY position. Let's go X and Y, and the width and height. So for the first one, we can have width and height, width of 50, height of 100. So that should draw our first rectangle. So you can see there's our red rectangle. Let's make the blue one. So we'll give it a blue style, fill style. Use rect to draw the other one. Let's see, let's make sure it's on the screen. And for the width, we can do 100 and 50. So now we should have two rectangles. Let's see, let's move these around just a little bit. Let's make them be overlapping. So then we're going to have them moving towards each other. I'll just move them to the edges of the screen. All right, so we got our two rectangles being drawn. So now to get them moving, we're going to have to use a variable to be keeping track of their position. So we need to have a global variable for their x positions. We want to track both of them. So let's do x1 for our first rectangle. And that's going to be 450. So let's move that. Let's use that there. And the other one, let's grab that one too. And so we're going to be updating those. So those are global variables, x1, x2. Let's replace those ones there. And now each time we're going to want to have them moving. So because they're going to be moving in different directions, we do want to track their speeds. So when they bounce off each other, we're going to have to change those speeds as well. So let's create two variables for keeping track of their speeds. One negative is going to be going to the left, one is positive, so it's going to be going to the right. And now here we can update their positions to have them moving. So we add them to the speed to them, and they will start to move. Not in the directions that we want though. Okay, let's just flip these around. Maybe 3 and 4. All right, so now they're starting to move to each other, but you'll see that they just pass through each other. So we haven't written any logic yet for when they're colliding. So to do that, what we're going to need to do is to create those bounding boxes. So we're going to have bounds 1 So let's use the bounding box function. And we'll want to use the position. We want it to be overlapping with our rectangle. So we want to use x1 for that. And we want to have the same y position. So we'll just copy paste these parts in there. And I'll just copy this over to make the second bounds 2. So that uses the x position of our second piece. And I'll grab these two as well. All right, so if we run this, there's not going to be anything different because all we've done is just defined that we have a bounding box and another bounding box. So even if we run it, you're not going to see anything. The bounding boxes are there, but they're not visible to us. So we draw the rectangles. There should be bounding boxes over top of them, but those aren't drawn. They do exist, but we're just keeping track of them in these variables. So to actually use these bounding boxes, we'll be using the collided function, and we want an if statement to be checking when they are collided. So if collided, and now we pass in our two bounding boxes, bounds 1, bounds 2. So now in here, we can write what do we want to happen when they do collide. So to make them bounce off of each other, we need to have we want them to start going the opposite direction. So we'll take their whatever speed they have, we want that speed to get flipped around so that it starts going the opposite direction. So to do that, we will multiply the value by -1, and that just flips the direction. Speed 2 times equals -1 as well. So now once they've collided, the speeds will flip around. And then when we are incrementing those positions, then they will start to go backwards. Oh, let's see, speed 1. So these ones are also global variables. I forgot to put that in. So speed 1, speed 2. All right, so they're coming towards each other. They've collided, bounced off very nicely. All right, that looks very, very satisfying. Let's run that again. Coming toward each other, colliding, and the speeds are flipped, so they start going the other direction. All right, so that's the code there again. So we had our global variables keeping track of x positions, keeping track of their speeds, creating the first bounding box, second one, checking if they're collided with the bounds, and then we have our logic for what we want to run. All right, so we're going to go through a little bit as to how this collided function works. How does it, what's the implementation actually doing? So we have two rectangles, so those are bounding boxes. And what we have to do is we need to have a check to tell us whether or not there's an overlap between those two rectangles. So the first part of that is checking the x-axis. So what we'll do is that what we have is that we have edges of these rectangles. And there's two parts that we need to have in order to know whether these parts are overlapping. So the first part is that the left edge, or the first one, has to be less than the edge of the second bounding box. So if the left edge were to be greater than that, then there's no way possible to have a collision. So this left edge here, if it were to be larger than the R2, meaning that it's to the right of it, then there's no way that we can actually have any overlap. So it's not actually happening. So that means that the first thing we want to check is this left edge of our rectangle actually to the left of it? And that means that maybe we have a collision. And then the next part, so if we know that the edge is to the left here, then we know that our rectangle is some kind of width in here. but it might be shorter than that, it might be here. So to find out that there isn't actually an overlap, meaning that there's a portion that's over top of this, what we want to check is that the other edge, that the right edge, is past this left edge. So if our right edge is actually past it, so if it's any point past this edge, even if it's way out over here, then we are going to have an overlap. That rectangle is overlapping with the second one. But if it weren't, so if that edge were to be over less than this edge in here, any point up to here, then we can see that it wouldn't actually be overlapping. So those two parts, we put those together, and that tells us that there has to be some kind of area that's between those two rectangles that is overlapping. Now, remember that this is just for the x-axis, so we're only looking at basically these sides here. So the other portion to that, of course, is that you can have the y-axis as well, and it's the exact same check. So we basically do the same thing, checking with the top versus the bottom, seeing whether or not you have this overlap, whether or not they're overlapping in this axis, in this axis. And then all together we combine both of those. And if it's overlapping in all those cases, then that means that there is a overlap between the two bounding boxes. All right, you don't have to worry too much about exactly how this works. We do that function is all you have to use, but this is just what's happening internally. Someone realized that they've been hard coding it. So yeah, that's great that you've been already doing something like that. All right, so for collisions and bounding boxes in games, so games do need to have bounding boxes to be checking where those collisions are happening. So the Flappy Bird, you would have a bounding box for where the pipes are and a bounding box for the Flappy Bird itself. And then you can then check the collisions. If a Flappy Bird is colliding with one of those pipes, then it is game over. For Mario here, we've got bounding boxes for the level itself. So, and for all the monsters. So this lets us know where Mario can actually fit through, where he can't have a floor that he can actually stand on. So if he's colliding with something, he can't walk through the pipes, but he can also jump onto the monsters. He can stomp on them. So those collisions let him interact with the environment. All right, so we're on to the first exercise. So you'll use the stroke rectangle and to be following the mouse. So you'll use a bounding box for that rectangle and then create a target that moves side to side. And then when the mouse is pressed, then if there's a collision, if there's a collision while the mouse is pressed, display the text that you got it. All right, so we'll move you out to breakout rooms and we'll give you 15 minutes to work on this. All right, looks like we have everyone back now. All right, so let's try going through this exercise. So the first part was to use the stroke rect. So that creates that hollow rectangle, have that following the mouse along. So that's the first thing that we'll try implementing, is getting that stroke rect going. So that one has like a reddish outline. So let's do stroke fill, stroke style, red style. Then we use the stroke rect to draw that rectangle. So we want to put that where the mouse X is and use the mouse Y. Then we'll set the width and height. So now when we draw that, You can see that it's drawing it, but we do want to have that background as well. So we'll set the background. So now we've got a great background. It's a little bit offset, so our mouse X is drawing it exactly at the top left hand. So if we want to adjust that, we can subtract 15 from there, and the mouse Y minus 15. And so now it's centered right where the mouse cursor is. So that code, that gives us a rectangle that's just following our mouse. So now let's create that target. So for that target, that's our blue target that we've got there. So we need to give it a blue fill. And we'll use fill rectangle to draw it. So let's start with drawing that on the screen. Set the width height 20 by 20. So we've got our target there that's now being drawn. Now we want to have it moving back and forth. So to do that, we need to keep track of that X position. So we'll need to use a global variable again. So let's call that just our X position. And we need to use, make sure that's, we are saying that it's a global variable. Put that in there. And now to get it moving, we will use, we'll increment it, but let's use a speed as well. Because if we want it to be moving back and forth, same as last time, we want to be tracking its speed as well. That's also our global variable. So now we'll have our blue square that's now moving. So now we want to have it bouncing back and forth. So for this one, we're not going to use a collision. Like we can't really do a collision with the edges of the screen. So we'll just have to use our own if statement to say that if the X position, if that is greater than the width of our screen, or if the X position is off the left-hand side, so if it's less than 0, then we'll want to flip it around. So we'll want the speed to go the other way. So now it's going to be bouncing off the sides of the screen. More or less, maybe it's going to go off a little bit. That's okay. So if we want to have it exactly bouncing off of it, then we need to subtract a little bit. So remember that right now, like the X position is the top left-hand corner. So it's going to be off the screen. So we can subtract basically 15 from 500, and then it's just going to be bouncing off exactly when it's touching it. Okay, so now we have our we've got a rectangle that's following our mouse. We've got our blue square. So now the last part we want to do is when it's colliding and when our mouse is down to be drawing that text. Okay, so we'll need to create our bounding boxes. So let's create that here. So we'll have our bounds 1. So we need to use bounding box, use the X position. It's mostly going to be the same. It's actually, sorry, it's going to be exactly the same because we want to have it overlapping with that rectangle. Let's do our bounds 2. Use bounding box. And we can just copy paste this one so it's exactly the same. And now we'll do our collision logic. Use collided and pass in the 2 bounds. So when it is colliding, we'll run this code. And let's do that if the mouse is pressed as well. Then we'll have some text So let's set the color of the text. Let's just make that black. And we can use text size to make it a larger size. And the text function that's going to actually draw the text on there. And there's our string, so that's the message that gets drawn. And now we just need to decide where to put it. So I'll put it somewhere around the top. So when we have to be pressing the mouse, so if we're pressing the mouse, and we can see that whenever it's colliding and our mouse is pressed, then the text appears. So it is a fair amount of code. So we had to draw the two different rectangles. We have the blue rectangle, that one's moving it. We have it moving back and forth. So we have our two bounding boxes, bounds 1, bounds 2. Got our if statement, checking if they're collided. And if the mouse is pressed additionally, then we are drawing our text message there. All right, so now we're going to go to the last bit of content. And that's going to be images. So far we haven't been able to draw any nice looking images. We just had our rectangles. So there is a function you can use, it's just called image, and that lets you use image files from your computer. So those are the PNG or JPEG files. You can use that and you can draw very nice looking scenes, nice looking characters. So you can find these images anywhere off the internet to use in your games. We also provide a few in the slide, in the speaker notes. You can find some links to these images too. So using this function, we've got image. The first parameter is the image name. So this is the file name, and you need to put it exactly in there along with the extension. So if it's a PNG or JPEG, you need to have that extension on there as well. And then you have the X and Y position where you'd like to draw it, and then the width and the height that you want it. And when you draw this, you want to keep the same width or height, so you don't want to be changing it each time that you're drawing it. You want the width and height to just stay the same. And that's just a bit of a limitation of the library that we're using. So where do you actually get these files? So these files, you do need to, once you've downloaded them, you want to put them into your notebook. So you can just drag and drop them into the Jupyter Lab, and they will show up as files listed along with the other parts there. So you can see I have the background.png here, and so then when I'm using that, I will use that name exactly. So this example here, if you have cowboybaby.jpg, then you would use this line here. You'd have image, and then as a string, cowboybaby.jpg. All right, so I'll create a new cell just to show that working. I'll put that into our dev setup. So the image function, that's what we're going to use. And the name of our file, that's background.png. So I'll put in background.png. And now I can set where I would like to put it. So I'll just offset it a little bit, 10, 10. So that's the X and Y position to draw it. And then the size of it. So I'll put in 400 by 400. So it doesn't seem to work the first time for some reason, but if I run it a second time, it does seem to be working now. So that's the image from the file I have there. So you can see that it's getting drawn there. And just a hint that PNG files can have, if they have transparency, then that's going to work very nicely. They won't have a white background. They will work very well. So here's the example. So you can try this out, that in the slides, there is, in the speaker notes for this slide, there is a link to the background.png and for the spaceship as well. And that's pretty great for a if you want to create a spaceship for a game. That's going to work really nicely. So the question about, does the image function replace the background function? So you can use so if you want to draw the a nice background, in this case, yes, it is replacing the background. So if you wanted a solid color for the background, you can use the background function, pass in the color that you want. But in this case, we want to have a nicer looking background, so we're using an image for the background instead. So to make sure that it covers the full screen, you can see that we've set it to be have the same width and height as our entire canvas. And then we've set the XY to be from the very top left-hand corner. So that draws the background for us. And the spaceship, it follows the mouse. So we set the X and Y to be, so I think this might be a little bit, you'll have to subtract a little bit from it probably in order to actually have it centered on the mouse. But this will let you have the image following wherever the mouse is. All right, so now it's your turn to try this all out. So we're gonna talk about the projects. So the projects are optional, but you can get a lot of Ignite points for it, up to 250. So there's gonna be marking based on 5 categories: readability, efficiency, novelty, functionality, complexity, and you'll have up to 50 points for each category, up to a total of 250. There's a link here to the rubric and to for each category description. You can submit as many projects as you like. There is a deadline for these projects. It's April 15th at midnight. And that's a deadline for everything Ignite points related. So for submitting the projects, there's the 2 links here. Use the one for whatever group that you're in. So it's the same process as for those weekly exercises. You just create your notebook file and submit it through the forms. So just some final information. So if you want to present the project during the Gala event, so that's hopefully you've heard about the Gala event, and I hope you've signed up already. We'll give you a link to that later today. We'll definitely give you a link to that. That's on the April 17th. So if you want to present a project during that event, make sure to have it ready before then. If you need any help with the project, join on the Discord channel. You can ask any questions there to your mentors, or you can show off your work as well. Get some inspiration, talk to other people. If you want to get a shout out on your project on the social media page, let your mentor know. So next week, we're going to be playing a game of Kahoot on everything that we're learning, and there's going to be some Ignite points for the top scores. The rest of today is going to be for you to work on whatever project that you're interested in working on. So now it's all over to you, that you can do whatever you're interested in doing. There is some exercises for this week as well, though. So for the Bug Busters, we've got it looks almost like a game. So we've got two images, cactus and some kind of character. And these images are in the speaker notes. And on the other one here, we have a block that you're moving, and it's colliding with a moving block there. And for the Pythonic lava, we've got a spaceship game now. Collides, so you have to check when it collides with some bullets. And in here we've got, almost looks like Pac-Man. So I think this might be with a keyboard that you have to use to move the character. And again, these images, you can find them in the speaker notes. Some project inspiration. So we have the code for this. I think there should be a link in the speaker notes for these ones as well. All right, so that's all the content for today. So now we're going to move you to breakout rooms, and we're going to have until the rest of today's session to you can work on those exercises, and you can also get started on your project.